Welcome, everyone. The room's full. The doors are closed. Before we got going, I just wanted to let folks know, now you're all in here, but you might know people outside who weren't able to get in. We are doing a repeat session tomorrow morning at 10 o'clock. So in case you meet folks who wanted to get in here and then they couldn't, that would be awesome. So welcome. Thank you for staying till late in the afternoon. We stand and after last night, I can only imagine, right now is about when people are starting to fade, and there's another party right after this, so that should be fun. So if 10 o'clock nobody shows up, I won't take it personally. So this is the talk for the Amazon EC2 container service. My name is Deepak Singh. I own the container service team. With me, I have Dan Gardesmeyer, who's an engineer on the team. I'll do the fluffy, pretty pictures. Dan will do the real talk. We'll see how that goes. Starting with pretty fluffy pictures. This is actually a view out of our team's little pit. We have a great view, and it was not taken before we walked into this conference. It's from a few months ago, when you can actually see the mountains and enjoy the sunshine in Seattle. It's quite pretty, actually. But we are here to talk about containers. As I can imagine from the line outside this talk, the applause this morning, and some of the lines I've seen for the Docker talks in this conference, people are super interested in containers and how they can be used in their applications, and everyone seems to be trying them out in one way or the other. And when we say containers, for all practical purposes, we're talking Docker. And after this slide, containers and Docker are pretty much synonymous with each other. I won't try and disambiguate them at all. So the goal of this talk, and as we started talking to customers who've been running containers in various forms and Docker on EC2 for quite a bit of time, it became pretty evident to us that for the kinds of workloads our customers ran, Docker and the cloud in general, EC2 in particular, made a ton of sense. But our goal and what we wanted to do was, as we realized that all of this, the cloud and EC2 was like peanut butter and jelly, could we really, really, really make it a delicious meal? And that's what we started off doing. So why are customers running Docker in the cloud? These are not necessarily just AWS-related features. It could relate to running Docker anywhere, but I think they get even better when you run in a dynamic environment. One was environmental fidelity. People have different kinds of environments. They're running Docker on their laptops. They're running them in test servers. They're running them in multiple EC2 regions, for example, AWS regions. And they want to maintain a consistent environment across all of them. Docker makes that pretty easy. People want to do deployments, especially the kind of immutable deployments people have started doing. Again, the number of folks who have pipelines that use Docker underneath to do deployments is just mushrooming. It obviously works really well for that. And I think it gets really, really interesting in a very dynamic, in a world where you have dynamic fleets. If you want to do dynamic fleet management and utilize your fleets even better, the way I like thinking about it is people went from servers to virtual machines to get better utilization. They went from virtual machines to running in the cloud where you have dynamic fleets to get even better, more dynamic utilization. And when you apply resource level management to it, it gets even more, you can be even more efficient with how you're using your resources. And finally, I think this is where things got really interesting, and what interested our team was people were starting to build some really interesting applications using Docker, which was, it's a natural evolution of how things have gone, where you start decomposing applications and you start writing them up as services. If anybody's been to any of the talks that some of the senior Amazon people have given, you've probably seen the pictures of the service map of the Amazon.com homepage, which is like hundreds of services that come together. And we've been doing that for years, but I think as more and more people start adopting that kind of service-based model, things like Docker came along, and I think they just reduced the barrier to making it easy to develop like that. So we wanted to make that running applications that use Docker underneath the hood, whether you're using it for deployment, especially if you're using it for distributed applications, we wanted to make that experience really, really good. So we did what we do well. We took a step back and started talking to a bunch of folks to understand what they wanted to do, what they were running, how they were doing it, and we learned a few things along the way. We learned that there were some barriers as they started expanding their usage of Docker and Docker-enabled applications on the cloud, as they were running applications that had tens of containers, hundreds of containers, and in some cases, thousands and hundreds of thousands of them, which were running on many, many instances. They ran into certain challenges. And these included things like cluster management, which is, okay, I'm now maintaining a cluster of machines. I have to keep tabs of it. I have to maintain the health of that cluster. I have to get cluster metadata. I have to monitor that cluster. How do I do that? Perhaps the one that gave people the most angst was, how do you maintain cluster state? How do you make decisions when machines go away, or in an extreme case where it could happen is an entire availability zone, for example, has some issues. How do you respond to that? How do you get cluster state? How do you respond to that? And people had built pretty elaborate architectures to make sure that they were being able to do this, but it was an operational nightmare. As their fleets were getting bigger, they had to start figuring out where all their containers were, what they were doing. People had implemented interesting monitoring pipelines, ways of tracking resource utilization. There was another thing that was keeping people awake at night. And then you have the standard problems that you get when you're getting really big, availability and scaling. And all of these things are tightly intertwined. The one that we started seeing more of, especially as we ran into customers from, who were starting to deploy in production, most of the folks we were talking to were starting to explore, starting to rewrite their applications, but there's a certain class of people who are running in production, or customers who live in a world where they want to be careful from day one, and that was around security, and they wanted to figure out, they had questions, they weren't sure what the right security models and constructs were, which were keeping them from actually going full bore and doing interesting things with Docker. The second side of the feedback we got was around features that our customers have learned to love, they use extensively and help them write really good applications. And these are features that we keep developing and adding. Good examples of that would be things like elastic load balancing. One of the most common feature requests we got as we started talking to customers was, hey, I'd love to put containers behind an ELB. I'd love to have each container get its own elastic network interface and IP. Could I start using containers with EBS? I'd like to be able to do that. Tagging was another common one. Perhaps the most, not surprisingly, autoscaling came up again and again. Hey, I want to use autoscaling for various activities, fleet management, reacting to load, etc. And then came in the availability and security aspects of it, which were, hey, I want to run across multiple availability zones, and how do I manage that? I want to be able to use identity and access management, apply roles and security groups to my containers, make sure that people in this business unit and people in another business unit can run in comfortably without interfering with each other. So these started coming up again and again and again. So when you think about it, what people are really asking us for is, can you make Docker-enabled applications first-class APIs in the AWS ecosystem? Can you give us an EC2-like experience with containers? And that's what we built. So the Amazon EC2 Container Service is a service that's designed to be a set of primitives that allow you to build applications, that allow you to build services on top of it, much the way EC2 does, and give you the kind of experience that people have become used to at the EC2 level, but now doing it with Docker. So what is it? It's a building block service, as I just said. We think about it in those terms as we think of the feature sets. We try very hard to imagine what it would be like for folks who want to build on top of us. Not just run applications, but actually build services of all kinds and platforms using us as a core building block. We had to get the cluster management side right. That seemed to be the challenge everybody was running into. So we did it, there's two things that it does. We manage our containers. So every container that you launch, we track it, we keep its metadata. You know what instance it's running on, you know what instance type it's running on, and you get a lot of other information along with it. And it manages cluster state. For those of you who have run large Docker-based cluster installations, you probably run some kind of state management system. With the EC2 Container Service, you don't have to. Everything is in one API call. We have an API call called describe cluster that you can, whether you're running one container, two containers, 1,000 containers, 10,000 containers, doesn't matter. It's one API call that gives you your cluster state. You don't have to run any state management system or any cluster management software. We also decided to build a scheduler. This is the first scheduler we've built. The goal of the scheduler is to give us a set of containers, and we try and find a place for you to run them efficiently. But because we also give you full cluster state, you can build your own. You can write any scheduler, talk to our describe cluster API, and then try and write the business logic that helps you place them. If you're using a scheduler today, it doesn't take that long to convert our response to what that scheduler is expecting. I've already talked about scale quite a bit, but in general, we wanted the effort required to run a few containers and the effort required to run 100,000 containers to be our problem, not yours. And we wanted this to be really fast. You don't want to be in a place where you launch 1,000 containers and it's taking you minutes, tens of minutes. You wanted that to also be in the seconds. That was another aspect that we wanted to achieve, and that's what ECS gives you. And we wanted to be secure. And the way we do this is, these are your containers and your instances. You launch the instances running under your account. These are containers running under your account. You get all the benefits that you get along with that. And they run inside VPC. So your clusters always run inside a VPC, which gives you can take advantage of the features that VPC has. And in the longer term, we'll be able to do more interesting things for networking in general. Apparently, I spelled security right, unlike the keynote. I was worried that I also spelled it wrong. So you can use security groups, you can use network ACLs, you can isolate. You get levels of isolation because you're using your instances and running in a VPC. And to talk about sort of the components and how our service is constructed, I'd like to hand this over to Dan.
Thank you, Deepak. It's amazing to see how many people are in this room and they share the same excitement and passion I do for this space. And so I want to walk you through, like Deepak said, some of the components in our service, and then kind of after that go into a demo, and hopefully the demo gods will be nice today and it'll all work. Talking about the components of the EC2 container service, we have 4 sort of runtime components. We have tasks, we have containers, we have clusters, and we have container instances. As task is sort of the unit that we use for scheduling your work, scheduling your containers, I'm going to start with that one. And so what is a task? What we think of as a task is a grouping of related containers. This could be one container, this could be many containers. They could be linked, they could have shared volumes, they could be not linked. And so what does this mean? And so that I'd like to go through an example. On the screen on the left, you see I have a box. That's actually a container, and it's running an Nginx web server. This is linked to a Rails application. And so this is a pretty common architecture where you might have Nginx put in front to do a lot of the heavy lifting, authentication, HTTPS, and then putting your business logic inside your Rails application. This Rails application is linked to a MySQL database for storage. And then it's also linked for a log collector that collects the logs from the Rails application and rotates them and uploads them so you can see them. So in this sample application, you have a couple links between your containers. You have a volume mounted into your Rails application. And the benefit of this architecture is that it's very easy to develop on a single place in a piece and to swap out a single piece at any port of the place of the application, but then we can sort of define this metadata around it to keep everything grouped together. And so how do we define a task? On the next slide, we have a task definition, and it's just 3 simple components. We have a family, we have a version, and we have a list of container definitions. And so a family is just a name that keeps your tasks together. So in the first example, we had Nginx Rails, some storage and a log collector. Ultimately what this comes down to is this is my website. And so I'm going to call it my website. If I want to change out Nginx for something else, if I want to change out Rails, if I want to insert more containers into this, I can while keeping this logical construct group together. Version is 1.0, and this is because it's the first version. Interesting thing here, though, is sequential versioning is oftentimes difficult. We understand a lot of you have automated build systems that build a lot of things all the time, and it's hard to go 1.1, 1.2, 1.3. And so version here, can take your Git hash commit, it could take a UUID, or you can do sequential versioning yourself. And the last thing here is these container definitions. And so I wanted to spend a little more time on what these are, because this is really the meat of the specification. And so what a container definition is it's a name for your container, and it also is the image that you'll be running. The image is going to be given in a standard sort of Docker format where you have your repository / name : and then your tag. So then you'll be able to pull images from Docker Hub. You'll be able to pull it from private repositories or anywhere where you want to get your image from. The container definition also includes default runtime attributes for your container. And these would be things that you would see if you were to do a Docker run command, like your environment variables, your port mappings, your container entry point and commands, and resource constraints. And sort of why we do this is because oftentimes these are very static, and they're really a key part of your application. Like these environment variables have to be there. And so by forgetting them at runtime, you're kind of putting yourself more prone to runtime errors. And so by checking this in and versioning it, you can keep it all the same. At the same time, Docker sort of made these runtime commands for a reason, and a lot of them will change depending on your environment. An example is that is you might pass in a command of a file that you're getting out of SQSQ, and you want to modify that at runtime. And so we allow the ability to sort of override your container definition when you are actually starting to run your task. And so an example of that, again, going back to the original example of the Nginx and the Rails application, is we have a name, and this name is just a web server. And this will be the name that's referred to if you create any links in later tasks. We have an image, and like I said, the image is just a standard Docker format like you'd see in a Docker run command. We have Nginx latest. CPU here is 512. And that unit of measure might be interesting for some of you out there, and that's actually in CPU shares. And I'll talk about that a little bit more in a minute after I kind of go down through the rest of this. Memory is in megabytes, so we have 128 megabytes of memory. In our container for Nginx, we're actually running it on port 9443. When that gets ran on our instance, it's going to get mapped through to our host port of 443, which is the default HTTPS port. We're linking it to the Rails application, and like I said, this is just the name of the next container definition that would be called Rails. And the last thing is a flag essential, and what this does is it's letting us know that if this container were to die, we would want to bring down your entire task because there's no meaning of the task without this container being part of it. There are some times where you might have a container where, if it finishes early or finishes a batch job, you might still want to leave up the other ones and let them finish, but they're still part of a task. But however, in this case, because Nginx is really fronting our web traffic, it is essential to our task. And if that were to fail, we would fail all the rest of the containers so they wouldn't be wasting your resources in your cluster. So I mentioned I came back to CPU shares, and this is a relative unit of measure. And so what this is saying is Nginx is guaranteed at least 50% of a single core in time for the container. And that's because when we register your instances with us, we check in with 1,024 resources or CPU shares per core. And so by saying 512, we're saying half a core. And now if your instance wasn't loaded with anything, your Nginx would get to burst up and be able to use all of the available resources. But as you started to stack more and more tasks, you're still guaranteed at least that amount of time. So we talked now about tasks. We talked about containers. And I want to move now into the other two components of clusters and container instances. And so a cluster kind of bridges this world. It really has two definitions. It provides a pool of resources for your tasks. So as you register these instances in, all the precious resources that you have of your CPU, of your memory, of your ports, because those are truly limited on a per server basis, get added. But it's also a grouping of all your container instances. So this is as you can check more container instances in your cluster, this available pool of resources grows. Many people like to call these container instances ships because they're kind of analogous as you're stacking containers onto a single ship. For the EC2 container service, this starts empty and it's dynamically scalable. So if you want to start off with a cluster of one instance, you can do that. And as you need more, you can add instances into your cluster. And as you decide you don't need them anymore because you have less tasks running, you can scale them down. There's no need to recreate the cluster. There's no need to do anything like that. So what is a container instance? I'm sure you guys are probably thinking that right now. And how does it relate to a normal instance? How do I use this? And when I talk about a container instance, it's really an instance that has our ECS or EC2 container service agent installed. And our EC2 container service agent is an agent written in Go that actually runs inside the container itself. It's responsible for checking the instance into your cluster. It performs all the heavy lifting of making sure that the containers on your individual instance stay up, and it reports all the information back to the service. We will ship a Amazon Linux version with our container agent already installed, with all the extra packages stripped out and all ready for Docker with the correct sysdetails specified, the correct kernel config, and really optimized for running Docker containers. So with that, I would like to jump into a quick demo to give you an idea of what this kind of looks like when it comes together. So first of all, like I said, we need a cluster. And so I'm going to start off by creating a cluster. So AWS ECS create cluster, and I'm going to name it default. And we get back a JSON blob, and I hope this font's big enough for those in the back. I didn't really want to make it much bigger, otherwise we might lose some space on the screen. We have a cluster ARN that we get back, and this is an Amazon resource name. For those of you who have used security policies, IAM policies, or if you have used SQS or SNS, this sort of syntax is probably very familiar to you. We have that cluster name that we registered with, and our cluster is now active. And so now we need to launch some instances into it, and so I'm going to go to the EC2 console, and I'm going to launch some instances. I have my AMI here created. It's the ECS version, enabled version of Amazon Linux. I'm going to choose some instance types to launch into it, and I'll just pick some M3 extra larges. They provide a decent number of CPU, a decent amount of memory, and a pretty good mix. So as far as number of instances, let's choose a number that will kind of display well on a screen so we can visualize this, but then also is more than one. So I'm going to pick 12. We're going to attach an IAM role to the box for it's the ECS container instance role. And what this role has in it is it has a IAM policy allowing my agent to check this instance into this cluster. So it provides all the credentials necessary to perform that. We're operating this in a VPC. Everything else looks good. So let's add some storage. I just chose 30 gigabytes because that seems like a reasonable amount of space to make sure that my container images will download and save. I'm just going to use the general purpose SSD storage. We don't need any tags. I have a security group here, and hopefully it will work. That will allow me to both SSH into my instance and also access HTTP. And so now let's go ahead and launch these 12 instances. And we'll go back to the home page. And so while those go ahead and launch, let's go ahead and prepare our task definition and get that ready to launch on this cluster. And so here I'll open up. I have one already, and I have WordPress. And this is kind of an interesting example because it's an application that many people are very familiar with. It also spans multiple containers, and so you'll see sort of the link functionality in there. We have a WordPress stackable container that's just being pulled straight from Docker Hub from a third-party developer who's gracious enough to build this for the community. And we also have a MySQL image as well from Docker Hub. Here you'll see kind of what we talked about before. We don't really give much CPU to these resources. We give a decent amount of memory to both. They're both marked as essential because if our database is down, the MySQL's pretty worthless. If the database is down, our WordPress is pretty worthless, and vice versa. We're passing in environment variables back and forth between the environments just to set up our database. And we have a port mapping from our WordPress to the instance. And so when this container launches, it's going to bind itself to port 80 on the host. We're going to have a Q&A at the end, and I'll take questions then. Thanks, sir. So here we have our instances running. And I go to this cluster view here. And this is just something that we built as a team. One of the developers threw it together in a night. It runs on my local host right here in a Docker container, actually. And what this is doing is it's calling our APIs, and it's loading all of the information about our cluster and our instances. So we can see right now 11 of our 12 instances have started up and have been checked in. They're all running M3 extra larges. We can see the IP addresses, the EC2 IDs as well. And then we're actually running 0 tasks and 0 containers. So I don't know what happened to that last one. Hopefully it will pop in soon. In the meantime, let's go ahead and take that WordPress and let's register it with the service. So AWS, ECS, and we're going to do register task definition. Make sure I spell this right. And we're going to give it a family of WordPress and a version. We'll just pick 1.0. We'll pass in that JSON. And we get back our response here. And so this response is very similar to what we put in. It tells us exactly that same container definition list that we had in that JSON blob. And then we also get a Amazon resource name assigned to it, which is the added line. Now that we've registered it, it was that easy, we're ready to run it. So we can just do AWS, ECS, run task, WordPress 1.0. And so it says it starts running. Let's flip to the UI really quick to see where it gets placed. And you can see now the container was placed on the first host right here. Yellow means that it's pending, so it's the containers are still being started up. So sometimes there's a time to pull the image or prepare things. And so now it turned to green, and so our images are ready. And so now if everything works according to plan, we can open up this link in a new tab, and we can see that we actually have a WordPress installation page already. So kind of going back to that data we got back from that run task, we get all this metadata associated of what is our task ID, what is our task definition ID that we launched it with, where was this launched, were there any overrides supplied, and what are they? And then we also get to know about what is our last status, our desired status of both at the task level and the container level. And so if I were to go and grab this task ID and I were to do a describe call on it, you would see now that our last status is running, our desired status is running, and both of our containers are running. So WordPress is a pretty cool example of a service that comes up, it stays up for a while. You might make some development changes and change it now and again. But we also, when we were designing and building the EC2 container service, we also wanted to think a lot about batch tasks and what does it mean to have something that's truly this fast, and how can I take advantage of something that's so short running that I can just spawn it up, it can run for 10, 15, 20 seconds and come down and get out of my way. And so I have an example of that. It's not the most interesting example in the world. All it does is sleep, but it kind of gives you, it kind of shows you how you can start up these tasks that will only run for 30 seconds, and they start up so fast, they come out of your cluster so fast, you have the resources available for anything else, and you don't have to worry about where you're placing them or anything. And so I actually have these already registered, so I can here do a describe task definition on sleep. I'm sorry, list. And you see we have 3 sleep tasks. We have one that lasts 15 seconds, one that lasts 30 seconds, and one that lasts 5 minutes. And here again, this is an example of how we take arbitrary strings as versioning, and whatever really works for you for versioning works for us. And so we can go ahead and we can repeat that previous command, and we can just feed this all into our run tasks. And we can launch 10 of each of these. And so for those of you who are familiar with xargs, it's just going to pass the output of the previous command that came out of standard out as arguments to the next. So now it's going to start 30 different tasks. across all my instances. Some of these are going to run for 15 seconds, some are going to run for 30 seconds, some are going to run for 5 minutes. And so you see they all start popping up across my cluster. They all get placed sort of spread out evenly for the most part. Some things end up getting placed a little bit closer than others. And some of these are going to start up, they're going to turn green, some of them are going to turn red. You're going to find them falling out of the cluster for the ones that lasted 15 seconds. The ones that lasted 30 seconds are going to stay a bit longer, and the ones that are going to have 5 minutes are going to stay the longest. And all the while, my WordPress is still up and running, so I can share these hosts for both these long-running workloads, such as services, as well as do batch processing to absorb some of that extra space and increase our utilization. And so here we see some of our busy boxes stopping, and the remaining are left. And so with that, I'm going to end this demo very similar to the one that we did on stage during the keynote. For those of you who saw it, I'm just going to list all our tasks, and I'm going to pipe that into stop task and kill everything. And as those process now, we can flip back to our UI, and we're going to find ourselves, as this refreshes, with an empty cluster. And so now everything's empty, and we can tear down our cluster. And with that, I would like to hand it back to Deepak.
All right. I hope you like that. I mean, it was a very simple example of the kinds of things that you can do with EC2 Container Service with a nicely hacked up UI that we put together very quickly. So what's coming? We are working on a number of things which we hope to add, sort of in the time that we're in the preview before we go out as a public launch. Things that the team is working on is actually some of the features that I talked about earlier that our customers want from us, which is elastic load balancing integration, where you'll be actually able to put individual containers behind an ELB and load balance across containers. You'll be able to take a look at all your, you'll be able to look at cluster utilization and similar metrics in CloudWatch. Once you have those, you can do interesting actions like trigger an auto-scaling group, for example. We'll be able to stream logs into CloudWatch logs. We'll be adding in support for CloudFormation, where you can describe your entire stack in a single CloudFormation template, your EC2, your networking, your containers, or tasks in our world. We want to add support for tagging, where you'll actually be able to tag individual containers, which will allow us for some interesting architectures as well. As you can tell, we need a UI, so we'll have one. And we're also working with our partners on adding our agent into onto their AMI. So when you just have to use ours, you can write your own once our agent's available, but you can also start with an AMI from our partners. Example, we're working with the folks at CoreOS, that you can take the CoreOS AMI with our agent installed and launch a cluster using that. Pricing, most of you are there at the keynote, so this is probably not a surprise, but there's no additional charge. You pay for the EC2 resources and any other AWS resources that you use with the service, but the Amazon EC2 Container Service itself doesn't have any cost associated with it. And you can sign up for the preview at that URL. Thank you very much. We'll be around for questions.